Welcome to the next lesson in the module on classes in Java, which explains how classes and methods can be generalized so that they can be reused with generic parameters of different types. After completing this lesson, you'll understand how Java generics enable the passing of types as parameters to the definition of classes and methods. You'll also recognize the benefits that generics offer to Java programmers, including stronger type checking at compile time and greater code reuse. Finally, you'll know some of the restrictions associated with using Java generics effectively in practice. We use the account class covered in a previous lesson as a running example to demonstrate the application of Java generics. Since Java generics are a bit trickier to use than conventional Java classes, we provide many URLs at the bottom of the slides that will give you further insight into using Java generics properly. Recall our earlier discussion about the number field in the account class we were building in the previous lesson. We initially defined this field as an int data type. After we worked with the class for a while, we made the design decision to change the number field from an int to a string type to accommodate the way we were generating account ID numbers. One issue that arises from this change is how it affects reuse. In particular, one of the many aims of a class is to reuse it in many different scenarios. Suppose the string account number was suitable for some uses, whereas the int account number was better for others. Should we create two different classes, one of each implementation of the number field? This approach isn't scalable, since multiple versions of the same class are harder to maintain and evolve over time. Moreover, the rest of the account class works just fine for both types of projects. What about including two fields in the class, int num and string num, and only use the one needed for any particular implementation? That approach is also a bad idea and will lead to errors and confusion later down the road. Fortunately, we can find a good solution in Java generics, which is a variant of the generic programming paradigm that allows algorithms and data structures to be written in terms of a placeholder type. These placeholders are later filled in when concrete types are provided as parameters, when an object of the generic class is instantiated. A Java class can be parameterized via the Java generics feature, which enables the passing of abstract data types, or ADTs, as type parameters to the definition of a class and its methods. As a result, the class's methods can be written once, yet are able to operate on objects of the generic class instantiated with various ADTs, all while providing compile time type safety. For example, we can apply Java generics to define the account number type as a generic type parameter to the account class discussed at the beginning of this lesson, rather than hard-coding the number field in the account class as either a string or an int, or writing multiple versions of account. Objects of the generic account class can be instantiated by passing the desired numbered type, such as string or integer, as a type parameter to account. Note that in Java 7 and beyond, the compiler can deduce the type arguments to the new operator, so it doesn't need to be provided explicitly. A generic class in Java is defined using the syntax shown on this slide. The type parameter section is enclosed by angle brackets, which follow the name of the class. This section specifies the type parameters, such as T1, T2, up to and including Tn. For example, it's easy to update the account class to use generics. You simply create a generic type declaration by changing the code public class account to public class account number, which introduces the type parameter number that can be used anywhere inside the account class, such as the type of the number field as a parameter passed to methods and as a return type of methods. Generics offer several benefits to Java programmers. First, they eliminate the duplication of code adhering to the don't repeat yourself principle, which states that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. For example, rather than having to maintain multiple implementations of account class with different representations of the account number field, we could instead have a single, generic account class that's parameterized by the type of account number, such as string or integer. Another benefit of Java generics is that they ensure compile type safety when operating on different types of ADTs. For example, an account object parameterized with the string ADT will not accept a value of type integer. Likewise, an account object parameterized with integer ADT would not accept a value of type string. There are some restrictions on using Java generics that you'll need to know to use them effectively in practice. In particular, it's not possible to instantiate generic types of primitive types. For example, the generic account class cannot be instantiated with the primitive type int, but instead must use the non-primitive integer type. Likewise, it's not possible to create a new instance of a type parameter. For example, a default number cannot be created, though Java Reflection can be used to accomplish this sort of initialize for general type parameters whose constructors require no arguments. In addition, it's not possible to declare static fields whose types are type parameters, since static fields are shared by all non-static objects in a class. For example, we can't define a static default account number field in the account class. These and other restrictions of Java generics are largely due to its type erasure semantics, where the Java compiler avoids creating new classes for parameterized types to ensure generics incur no runtime overhead in the Java virtual machine. Whenever there are multiple ways to represent key properties of a class, it's worth considering whether these variations can be handled via Java generics. Now that you've completed this lesson, you should understand how Java generics enable the passing of types as parameters to the definition of classes and methods. You should also recognize the benefits that generics offers to Java programmers. Finally, you should know some restrictions associated with using generics effectively in practice. When generics are used properly within the constraints of Java's runtime environment, they provide powerful capabilities, such as stronger type checking at compile time and systematic reuse via generic programming. Generics are used heavily throughout Java's class libraries, especially the Java Collections Framework, which defines generic classes to implement common, type-safe, reusable, abstract data type collections, such as ArrayList, vector, and hashmap, which in turn can be parameterized by other types, such as an ArrayList of integers, a vector of doubles, or a hashmap of employees. For more coverage and examples of Java generics, especially its advanced features, such as wildcards used to represent unknown types, please see the tutorials listed on this slide.